All right, so now let's talk about lighting. So the beautiful thing about this setup and this type of setup is that a little bit of lighting goes a long way. You do not need to have a super complicated light rig setup. And in fact, for this project and that final render that we saw, I used two lights. It's one key light and a geolight. Now, granted, this geolight is going to be on some points that are scattered throughout the system here. So it is going to be giving us light from different areas. But I just wanted to illustrate the point that there are technically two lights in this entire setup. It's about taste and about look and achieving a look. Sometimes less is more. And so that's what we're going to go with here. So for this setup, I have a key light, which is basically just an area light. That's right in here. That's going to be giving us sort of that hot area on this main chunk here. So basically, if I turn off this background volume, you'll see that we have our hero nebula piece and our midground nebula piece. Now the midground and the background are going to be lit up primarily by this geolight, but this hero piece, we're going to be hitting it by this key. And so if I tumble around, you'll see that key light is really going to be sort of creating a rim and a nice hot saturated section on this backside that then when we look at it through the shot cam is really gonna rim this area out and define that shape for us. So with this key light again, nothing really complex or crazy going on in here. It's just pumped up the exposure to 5, and the light intensity itself has just like a little tiny tinge of color to it, but nothing crazy. You can copy this value if you want. And then down here for this geolight, actually if we want to, I can dive in here. And we'll see the way that I set this up. If I just hide the other objects, and we start from the top. We basically just have a grid, and then I move that grid to be down, nestled in to our layout of the nebulas, and I'm scattering some points onto it. Just to make that a little bit easier to see. Geometry, change that from disks. If it will let me, there we go. We can just change that to points. So now you can see down here, we just have a handful of points scattered. I'm going to turn off the grid just so we can see. Now it might be a little hard to see down there, but we do have a little cluster of points. There you go. Now you can see them. And so then we're going to take that little cluster of points and we're going to run them through a point vop just to scatter them around. And then run them through point wrangle, giving them a little bit of p-scale change. And then we're going to run a copy to points, and we're going to instance a sphere onto each one of those. I'm actually going to kill the point wrangle just so that you can see them a little better. So now you can see positionally in the world, each of these guys is going to act like their own light source. So if I come back and ghost our other objects, give them a second to load. You can see that those lights scattered around are really going to help fill in the lighting of this volume layout. So if I go back to our shot cam, and now you can see we've got this guy that's going to end up being a nice warm hotspot nestled right into the center of that background volume. And then a couple guys that are going to end up being out here in the foreground. This guy's going to be a little bit further out there. But you can see how those spheres are going to nestle in and contribute their light through the layout that we have. Okay, so now that's how I set up the geolight system. And then now those geolights are going to be pumped into this setup here. Exposure, I took it up to about 14. Again, you can play with that intensity yourself, whatever going to end up working for you. Now, one thing that you will run into, now I'm going to take a little second here and talk about these geometry lights because there's pros and cons to using the geometry light. So the main con is that at a lower sampling quality, the default of just being 1, it can introduce some noise into your render. Now, there's 2 ways to combat this. You can either start to crank up the samples in your actual render, but then that's not really helping you because all that's going to do is it's going to compound all the sampling for everything else that's going on when really it's only this one light source that's introducing sort of that noise. So that's what this sample quality is going to do for us here. Now, this is going to complicate things. And what I mean by that is the higher you go on the sampling quality, the render times are going to almost exponentially increase. So you're going to have to find that middle ground where you have the most cost benefit worked out between, a level of noise that's acceptable, but also versus a render time that's acceptable, because you don't want to get into days and days and days for a single frame. Ultimately, where we end up capping out in the final render of this is somewhere between 9 to 11 hours a frame. And that's because primarily this geolight is going to increase the render time. Now, ultimately in our final render, I dropped these sample quality down to 4. Really, anywhere between 2 and 4 will start to smooth out the sort of granular noise that will be introduced into the hottest hotspots in the render. But this is something that you're just going to have to play with and figure out what works for you, again, in a cost-benefit analysis between how much noise is acceptable in the render and how much time is acceptable for a render. But the trade-off for having to consider these things and to fight through that sort of stuff is that the lighting quality that you can get with a geolight, especially for a scene like this, is really amazing, and it's so quick and easy to set up. Otherwise, you would have to throw out a bunch of area lights and things like that, and then that can bring up its own problems and issues as you're moving through a scene and trying to render. Like if you threw out a bunch of point lights, say, in these areas, point lights are not going to be good for a volume type render like this because you're going to end up with a really hot pinprick at the center of where that render is, and that is killer for a render. It just looks so fake, but you get that same sort of radiating intensity from this geolight, and you can oversample it in a way that you can't with a point light. So you can really get rid of the noise that would be introduced if you had just a bunch of point lights in here. So I know that was a little bit of a long-winded explanation, but it's really important for you to understand these types of issues when you get to the latter stages of these kinds of setups where you need to actually get this stuff to render. Now, we have very complex things going on. These are very highly detailed volume simulations, and then you got to add in highly detailed lighting to go along with it. It's all related, it all comes together, and you really just need to keep that kind of stuff in mind. Geolights will give you beautiful, beautiful effects, but you will pay for them, okay? So that being said, this whole setup, again, is just a geolight setup, scattered some spheres onto points, use them as little light sources scattered about, and a key light. So we can look at the shaders. Now again, we don't need these. There's really only two shaders in this whole setup. There's one where we have the density a bit thicker and the shadow density stronger, and then one that's a little thinner. So this one here is going to be the shader that we use for our background object. It's going to be a lot thinner, more atmospheric, so it doesn't need a super high density scale, but it does need a little bit of an overcranked shadow density in order to pick up those details. And then the sparse fireball is a great shader to use for these types of effects. I mean, you can use any volumetric shader that you want, but I just key in on these because I like these shaders. I use them all the time. But now for these hero objects, the Midground Nebula and the Hero Nebula, they're going to share a shader with a thicker density because I want to thicken up that cloud and bring out the detail that's in there. And then a higher shadow density because I don't want that light to be able to really penetrate through all the way into that volume. That way we can really see that complexity and internal complexity. And it ends up looking really, really sweet. So again, this setup is super simple. It's 2 lights, 2 shaders, 3 simulations, and go. All right? So before we close out this section and go into the aftermath of just the render and the composite afterwards, just to sum things up again, there are, if I come back up to the object level, there are 3 sims, 2 lights, 2 shaders. And then in the mantra node itself, we're just forcing to render only the nebulas that we have, the hero nebulas. We're going to be using ray tracing. Now, for this type of effect, this is one of the only times that I'll use the ray tracer over the physical base rendering. Because for this type of a render and this type of a setup, really the ray tracing is going to be much, much, much faster than the physical base rendering, like by, in some cases, almost twice as fast. So for these setups and these volumes and nebula simulations that I run, I'll run those through with ray tracing. Now the pixel samples, we just had them set at 3. Because volumes render pretty well. They don't need a ton of pixel samples. Where the slowdown in the render comes is, again, like we said, in the geolight, having to oversample the geolight, because if we were to render this scene without the geolight, just at 3 and 3, it would be pretty darn clean, but it would also be a little bit boring. That geolight really gives us some really good looking effects. So that's why, I'm willing to pay for it. You got to pay for quality. So that's really it for that setup. And then the only things that are going to be important for us for compositing down the road with these types of setups is position, depth, normal, and then I like to do a breakout for per light. That way, if I need to, I can break out just the lighting contribution from the geolight versus the key light, okay? And then now another thing that is good about these volume rasterized particles versus just like a normal volume render is you'll actually be able to use some z-depth information from this setup, because a lot of that depth information was inherited from the geo of the particles. So that's a good thing as well. That might be in people that render volumes all the time, you'll often run into the fact that you can't pull a z-depth channel from volumes, but you can from this setup. So I always have the shading depth on there as well. All right, so that's pretty much it. So we have our 3 simulations giving us our midground, hero, and background nebulas. We have 2 lights in the scene and just an animated camera that's just going to swoop through the scene. So we'll go ahead now, we'll render it, and then let's meet back up in Nuke, and we'll talk about compositing all these elements back together.